Hello kids, in today's class we are going further in this chapter and we have a question called Mathapachi. It says that Akshi and Toshi, they start running along the rectangular track as shown in this figure. So Akshi runs along the outer track and completes 5 rounds and Toshi runs along the inner track and completes 7 rounds. Now they are wondering who ran more and also find out who ran the longer distance. So what we have here is we have two girls, Akshi and Toshi, and they start running around these rectangular tracks. We have one green rectangular track, that is the outer one, and the mustard one, the yellow one, you can say is the inner track. That is a smaller one comparatively. And the dimension of these two tracks are given to us. The length of the outer track is 70 meters. The length of the inner track is less than that. It is 60 meters. And similarly, the breadth of the outer track is 40 meters and the breadth of the inner track is 30 meters. Also, the starting point for Akshi and the starting point of Toshi is also mentioned in the figure here. Now, each track is a rectangle which we have seen. Akshi's track has 70 meter length and breadth of 40 meter, and running one complete round on this track would cover 220 meters. So kids, we know that the outer track, it's a rectangle and the length and the breadth is given to us, and if we want to know the total length of this track, then we have to find the perimeter of the outer track, and we have a formula twice of length plus breadth. Length is 70, breadth is 40, and we can find out the perimeter, that is the distance of this outer track, that is 220 meters. This is the distance covered by Akshi in one round. So if Akshi takes one complete round of this track, she has to cover 220 meter because she will be covering the perimeter. Similarly, we can find out the perimeter which is covered by Toshi. And if we want to find out what we have to do, we just have to find the perimeter twice of L plus B, length and breadth. Length is 60 of the inner track and the breadth is 30. So we are just putting the values of length and breadth in the formula of perimeter, and this is 180 meters. So 180 meters is the perimeter of inner track. Okay, this is the perimeter of inner track. The perimeter of outer track is already calculated here. It is 220 meters. Now, on the basis of this figure, we have few questions to solve. Let's go through these questions. First is find out the total distance Akshi has covered in 5 rounds. So kids, here the distance traveled by Akshi in one round is 220 meters. It is given to us. And what we have to find is distance traveled by her in 5 rounds. So what we have to do? Simple multiplication. We will multiply 220 meter, that is the distance covered in one round, into 5. We will multiply it by 5 because we have to find the distance travel in 5 rounds here. And if we calculated, this will be 1100 meters. Okay, so this is the distance covered by Akshi in 5 rounds. Now similarly, find out the total distance Toshi has covered in 7 rounds. So right now we have find out the perimeter of the inner track. So perimeter of the inner track is 180 meter, and this is the distance traveled by Toshi in one round, right? And what we have to find? The distance traveled by Toshi in 7 rounds. So what we'll have to do here is just multiply 180 meter, which is the distance in one round, into 7 rounds multiplied by 7, and when we will multiply this, we will get 1260 meters. This is the distance covered by Toshi in 7 rounds. Now coming to the next one, who ran a longer distance? So it is very clear that 1260 meter is greater than 1100 meter. So it is Toshi who has covered more distance in 7 rounds than Akshi in 5 rounds, right? So I am writing Toshi here, and we know how we have calculated this, right? Now Yes. Next, what we have here is question number third, first part. Mark A at the point where Akshi will be after she ran 250 meters. So, kids, what I'm doing here, I am, wait, solving it here. Okay, this is the A part. We have to mark A in this track where Akshi will be after she ran 250 meters. So kids, we know that when Akshi, she is running in the outer track, in one complete round, she is covering 220 meters of distance, right? So I'm writing it here. Wait. Yes. So one complete round covers 220 meters in outer track. And what we have to do, we have to mark A at the point where she will be after 250. So that means what we have to do is, when we subtract 220 from 250, we will get to know the additional distance she will have to run after she completes one complete round. So this gives us 30 meters. So that means on the outer track, she will first complete one full round of 220, and then addition to that, she has to run 30 meters more. Now let's go to figure and see. This is the starting point of Akshi, and if she completes one full round, that means she is going to take this outer track once, and once she will reach here, she will cover 220 meters. Now what she has to do, she has to cover 30 meters more. So kids, if you see all these dots, they are at the distance of 10 meters. See, this is the 70 meters given to us. So this is 1, 2, 3, 4, 5, 6, 7, 8. 8 dots here, and between every two dots there is a distance of 10. So that makes 10, 20, 30, 40, 50, 60, 70 meters. Okay. And similarly on the breadth side also, this is 10, 20, 30 and 40. So between every two dots there is a distance of 10 meters. And inside also this is same. Now coming back to the A part, she has to take one complete round of 220 meter, the outer round, and after this outer round, when she completes 220, she will take 30 meters more. So this is 210 plus 10 plus 10. So this is the point. I am marking this as A. Okay, so this is the point A where Akshi will be after 250 meters. I hope this is clear. First, we have to complete one full round of 220 and then additional 30. So 10 plus 10 plus 10 is 30. So this is the point where she will be after 250 meters. Next, what we have is, we have to mark a point B where Akshi will be there after 500 meters. Okay, so kids, now again I am just adding this part here only. Wait, I'm making this as B. Okay, we know that one complete round is of 220 meters, and we want to see that where she will be after 500 meters. So in one round she covered 220. In two rounds, in two complete rounds, she is going to cover twice of 220, that is 440 meters. Okay, if I'll take three complete rounds, it will be more than 500. Okay, so what we have to do is, we have to see that what is the distance we have to find out. If I'll take three rounds, it will make it 660, which is more than 500. So what we have to take, we have to see that how many full rounds she can complete in the given distance. So she can complete 440 meters, that is two complete rounds. And after that, how much distance is left? 500 is the total distance, 440 is the distance she covered after completing two rounds, and remaining is 60 meters. So that means after two full rounds here, she starts from here, she will take one round, she will take two rounds, and then she have to take 60 meters more. So till here it was 30, now 40, 50 and 60. So this is the point, I'm marking it this in red. This is the point B where she will be after 500 meters. Next is, now Akshi ran 1000 meters. How many full round can she finish running around the track? Mark her position at C. So now what we have to do is we have to calculate. Here I am again using the same part. Wait, I'm just removing this and this as well. Yes. So what we have to do is C part. In one round, we know that she covers 220. If I'll take 5 rounds here, it will make it 1100 meters, which is more than the given distance. So that means let us calculate the 4 complete rounds. So kids, by seeing the numbers, we can estimate that how many rounds she can take according to the numbers given to us. We know that if we multiply 220 with 5, the distance will be more than the given distance. So we are trying with 4. So when she completes 4 complete rounds, she covers 4 multiplied by 220 meters. That is 880 meter distance she covers. And now we have to calculate the remaining distance which she has to cover after 4 complete rounds. So when we subtract this, we will get 120. So 120 meters is the distance she has to cover additionally. So now let's go back to the figure and see that after 4 complete rounds of the outer track, she will reach here and then she has to take 120 again. So now kids, this complete length is 70. This complete length of the outer track is 40. So if I can divide this 120 meters into 70, that is the length of the outer track, and then 40, the breadth of the outer track which she will travel. This 70 plus 40 is 110, and additionally to make it 120 she has to cover 10 meters more. So why I am breaking this? I am breaking this because we are given a rectangular field, we are giving the dimensions. So it will be easy for us to locate it on figure. So this is 70. After 4 complete rounds, she will cover this 70. Then she will cover this 40. And then this is additional 10 meters which she is going to cover here. And she is going to reach here at C point. I am marking this as C. Okay. So this is the point C where she is going to reach. And how many full rounds she has finished? She has completed 4 full rounds. 4 full rounds and additional distance of 120 meter. Right? I hope this is clear, kids. Now, next we have D. Mark X at the point where Toshi will be after she ran 250 meters. So, first I am just erasing this part. And let's now go to the inner rectangular track where Toshi is running. Okay, so what are the dimensions of the inner track? It is 60 and 30, and we have calculated the perimeter also. So I can write here 1 full round of inner track is of 180 meters. And how much she has to run? She has to run 250. So kids, we know if we double 180, if I multiply it by 2 and try to see if she covers 2 rounds, it will be 360, which is more than the given distance. So how we can calculate that where she will be after 250? We have to subtract 180 from the given distance. So when we subtract it, we will get 70 meters. And now what we have to do? We have to locate X point after 250. So one full track, she's going to start from here. This is the starting point of Toshi. She is going to complete this full length. which is of 180 meters, and after that she has to cover 70 meters more. Now this inner track length is 60, so again she is going to complete this length and then additional 10. This is additional 10 for her. So that means I'm marking this in red. This is the X point. She will be here after 250 meters. Okay. Next we have E part, where we have to mark Y at the point where Toshi will be after 500 meters. So this is again easy, kids. What we have to do, we know that one full round is of 180 meters, and now we have to see 500 meters. If we take the table of 18, we know 18 into 3 is 540. That means she cannot take full 3 rounds. So what we have to do, we will try to take 2 full rounds first. So 2 full rounds of inner track is 180 into 2, that is 360 meters. So Toshi will cover first 2 complete rounds of the inner track, and after how much additional distance she has to travel, we can find it out by subtracting 360 from 500. This will give us 140 meters. Okay, so additionally she has to cover 140 meters. And again, what I am going to do, I am trying to break it as per the dimensions of the given rectangular track, so it is easy to plot. So we have 60 here and 30 here. So how can I break it? I can break this one as 60 plus 30 plus 50. Okay, so let's go again to the figure. We have this as 60 and 30 and then 50. 50 means here. So we can mark the point Y as here. This is the point where she will be after running 500 meters. Okay, so kids, I hope you understand this question. Next we have, now Toshi ran 1000 meters, and how many full round has she finished running around her track? Mark her position as Z. So I'm writing this as here. One full round is 180 meters, and the distance given to us is 1000. So if we multiply 18 with 6, the distance will be more than 1000, right? So what we are going to do, we are going to take 5 full rounds. 5 full rounds. This is 180 multiplied by 5 will give us 900 meters. So in 5 rounds, she is completing 900 meters. If we'll take 6 rounds, it will be more than 1000. So that's the reason we are not taking 6 rounds. So what we have is 1000, the total distance she has to run, minus the distance she has completed in 5 rounds. So that comes as 100 meters, which she has to again cover. And again, we can break this into the smaller parts of as per our dimensions of the rectangle. We have 60 as the length, 30 as the breadth, and then additionally she has to cover 10 meters. So let us locate it here. So so Toshi is going to start from here. She is going to take the 5 complete round of this inner track, and then additionally she has to cover 100 meters. So this is 60 she will cover, then 30 she will cover, and here is the last 10. So that means I'm marking it here. This is the point Z where she will be after 1000 meter, and in this covering of 1000 meter she is going to complete 5 full rounds. Okay, so this is how we have to do such questions, kids. Next question, we have deep dive. Okay, so what it says is, in races usually there is a common finish line for all the runners. This we know that although we have different tracks, but the finishing line is same for them. Now the 2 square running tracks are given to us, where the inner track is of 100. First of all, this is the square track. We have the inner square track of length 100 meter, That means since it's a square, all the sides will be of 100 meters and the outer track is of 150 meter each side. Since it's a square, all the sides will be equal again. Now, the common finishing line for both the runner is shown by the flags in the figure. This is the common finishing line also mentioned here, which are for both the runner is shown in the flag, which are in the center of one of the sides of the track. So this is the side of both the tracks and this is the center of these sides. Okay, and this finishing line is in the center of these side of the square tracks. Now if the total race is 350 meters, then we have to find out the starting position of the two runners should be on these two tracks so that they have a common finishing line after they run for 350 meters. So kids, what we know here is, we know that this is the finishing line, we know the dimension of the inner and the outer track, and what additional we know is that it's a race of 350 meters. But what we have to find out is, we have to find out the starting point of both the runners, A and B. Okay, so let us start with the inner track first. Okay, so what we have to do is, we have to mark the position of the person, of the runner, of the who's running in the inner track. So since what is given to us, we are given the dimension of this square as 100. Okay, and also we know that this line is in the center of this side. So that means this distance is 50 meter and this distance is also 50 meters, right? I am doing this question here, kids. Right? For inner track, I am writing inner track. Right. This is in the middle, so we know this is 50 and this is 50 here. Now, what we are provided here is 350 meters. We have to see that the runner runs 350 meters. So what we are going to do? We are going to solve this question backwards. 50 is given to us. Okay, so from this 350 meter race, if I remove this 50, that means that before this 50 meter runner is somewhere here, right? And now what he has to do, he has to cover 300 meters more, right? This is the total race distance. This is the half line distance which he has to cover to reach the finishing line, right? And what we have to find out, the 300 meters, we have to subtract it to find out what additional distance he has to run to complete 350 meters. So this is 300 meters. So this is inner square, it has a length of 100 meters each side. So this is 100, this is 200 and this is 300. So that means the runner would be somewhere here. Okay, so in that way he will complete 100, 200, 300 and 350. Okay, so I hope this is clear what we have done. We are given that this finishing line is in the halfway. So this is 50 meters and now we are going back to find the rest 300 meters, and which tells us that runner has started from here. So he will cover 100, 200, 300 and 350. Now coming to this I am marking here with red. I am marking this as A point. As per question, we have to mark the inner track as A. Now let's move to the outer track. Now kids, similarly for the outer track, each side is of 150 meters. That means this distance and this distance is 75 meters each. Why? Because this line is in the middle. Okay, so from this, for outer track, I'm writing here, for outer track, we have to calculate 350 minus 75. So this is somewhere 275. The person will cover 75 and then how much he has to cover? 275. So how we can calculate 275 here, kids? This is 175 plus 150. So this 150, if he covers, after that again if he tries to cover 150, that will make 300, which will be more. So after the person will cover 150 meters here, and then additionally how much he has to cover, we will subtract 150 from the 275, and this is 25 meters additionally he has to run. So that means person will run 75, this 150, and again this is the middle point, 75 of this, and 25 is 1/3 of it. So it will be somewhere here. So this is 25 meters, 150 meters, and 75 meters. This is the point B. I hope this is clear. Still, I'm telling how we have done this. For the outer track, we know that the side length is 150 and this line is dividing in equal halves. So that is 75. Now, to complete this race, we have 350 minus 75 because he has to travel this distance to complete the race. So that make it 275. The difference is 275 which he has to run. Now, one side of the square is 150. So if he travels one side, he covers 150. So what is the additional distance he has to cover? 25 meters. So this is 25 meters on this line which he is going to cover additional. Okay. So this is how we have to do such question, kids. Okay. Now, next we'll just try to do this very fast. Akshi says the perimeter of a triangle shape, this triangle given to us, it is 9 units. And Toshi says it cannot be 9 units and the perimeter will be more than 9 units. What do you think? So kids, if we see this figure, we have dots drawn here. And if you see here in the red line, the distance between the dots is same. But if you see these lines, the diagonal lines here, the distance which is highlighted with blue, the distance between two dots is greater than the distance between the red dots, right? The distance between the two dots is less here and it is more here, which is marked as blue. So that means since the distance between all the dots is not same, so perimeter cannot be 9 here. Now, let us see that why Akshi is saying it was 9. Because if we calculate this is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the way Akshi was calculating. But just now we saw that distance between the dots marked with red line and the blue line is not same. So it cannot be 9 units. So that means what Toshi is saying is correct. Now, the thing is that how should we calculate such distances? So kids, what we are doing here is we are calculating this as straight lines and the diagonal lines. Straight lines are this and these slanting lines, these are our diagonal lines. So how we can represent it? In this given figure, we have 1, 2, 3, 4, 5, 6. 6 straight lines. So we are denoting this with 6 straight units. 6S. And then 3 blue lines. 3 diagonal lines. 3 diagonal units are with 3D. So this whole perimeter can, in this figure, it can be described as 6S, that is 6 straight units plus 3D, 3 diagonal units. Now similarly, what we have to do is we have to find the perimeter of the given figures. So kids, here I am doing the first two for you and the next two you have to do. I am marking them, I am marking these points as A, B, C and D. I am picking A first. So in A, we have how many straight units? Let us see first. 1, 2, 3, 4, 5, 6, 7 and 8. These all are straight units. So we have P is perimeter as 8 straight units plus how many diagonal units we have? I am marking diagonal in red. 1 and 2. So we have 2 diagonal units. This is the perimeter. Now this unit can be anything. They can take the dimension of these units differently. Next, what we have is B part. In B part, what we have is, this is straight 1, 2, 3, 4, that's it. We have only 4 straight units. So I'm writing 4s plus, let us see how many diagonals we have here. So 1, 2, 3, 4, 5, 6. We have 6 diagonal units. And again, these units can be different. The straight unit and the diagonal unit can be different here. So in question, you can also get this type of question that, first of all, verify that what is the perimeter, and then the straight length, the value of the straight length can be 2 meters and the value of the diagonal length can be 1 meter, and then you have to calculate the perimeter. You can get such sort of question in your examinations. Now, next what we have is equilateral triangle. So kids, we have already done equilateral triangle in grade 5. What is equilateral triangle? It is a triangle whose all the sides are equal. So that means if I say the length, this is an equilateral triangle, then this length AB is equal to length of BC is equal to the length of CA. That means if this is 5 centimeter, then all the sides will be 5 centimeter. So if it is mentioned that an equilateral triangle ABC has one side as 2 meters, that means all the sides will be 2 meters. Okay. So this is the property of equilateral triangle. And what is the perimeter? Perimeter is again the length of 3 sides, AB plus BC plus AC. Right? But we know that all the sides are equal. So can I write BC as AB only? BC as AB only because these two are equal. So I'm writing this as AB. And again, since all the sides are equal, I can also write AC as AB. Right? Why I am writing this? Because all the sides are equal. I could have written all the sides at BC or AC also because all of them are equal. So perimeter will be 3 times AB. Okay. And what is AB? It is the length of one side. Length of one side. So perimeter of equilateral triangle is 3 times the length of one side. Okay. This is about the equilateral triangle. Now kids, what we have here is split and rejoin. So basically this is the activity where a rectangular paper chit of dimension 6 centimeters into 4 centimeters. This is a rectangular paper given to us and then it is cut into 2 equal pieces here. It is cut into 2 equal pieces and these pieces are then joined in different ways. So it was 6 into 4 first. Now what we have is 6 and 2, 6 and 2 joined side by side. So for this figure, what we have to do is, for example, the arrangement A has a perimeter of 28 centimeter. So how this is 28 centimeter, kids? Let's try to find out. We have this as 6. I'm writing it as here. Then we have 2 here. Okay, 6, 6 again, 6 plus 6 plus 2 again, and then this 6 also. Okay, 6, 6, 6 and 6. 24 plus 4 is 28 centimeter. So what they have done, they have cut this into 2 halves and they are arranging it in a different way and we have to find their perimeters. Let us try to do quickly in this figure only. So for this B part, what we have is this. This is 2, that means this is also 2, correct? And this length is 6 given to us. This was 6 till here. Now this is 6, this is also 6. This one is 2. And this is again the length, this is also 6. What about this? This is this complete 6 and minus this 2 because this was 2. So we have to subtract 2 from this. We will get 4 here. Okay. How we have done? See, this length is 6. 6 here and 6 here. 6 here also. This length is also 6. 2 is given to us here. If this is 2, this is also 2. And this is also 2. If this is also 2, this is also 2. And this total was 6. We have to subtract 2 from this. We will get 4 here. And now what we have to find? We have to find the perimeter. So what we have to do? We have to add all this. So I'm starting here with 2. I'm starting from here. 2 plus 6 plus 2. 2 plus 6 plus 2 plus 6 plus 2 plus 4 plus 6. Okay. And if we add all this, we will get 1, 2, 3, 6 and again 28 centimeters again. This is 28 centimeter. Okay. This is easy. Again, we have this figure. This one is 2. This one is 2. This is also 2. This is 6. This is 2. This is 2. 6 and 6. This one. Right? And now what we have to do? Simple addition of all this. How we can do this is 2 plus 6 plus 2 plus this 2 and this 2 and this 2. 2 plus 2 plus 2 and these 2 6. Okay. And if you add all these, again, we are going to get 28 centimeters. The last one, D part, this is 2, 2, 2, 2. This one is 6. This one is 6. Half is merged in this. So 6 minus 3, that is, this is 3 remaining. And similarly, we have 3 here also. Why? Because this complete length was 6. 3 centimeter has been merged. The remaining is 3 here and 3 here also. Because a part of this, that is 3 centimeter, it is merged with the outer one also. So now what we have to do? We just have to write. This is 6 plus 2 plus 3 plus 2 plus 6 plus 2 plus 3 plus 2. Again 6 plus 2 plus 3 here, then 2 plus 6 plus 2 plus 3 here, and then this 2. Okay, so if we'll add this, we will get 26 centimeters here. So this is also done. Last we have arranged the two pieces to form a figure with a perimeter 22 centimeters. So what we have is, let us try to arrange them in a way so that we get 22 centimeters. This is 1 bar with us, 2, 2, 6. Okay, I'm just trying to do this first like this. Again, this is 2, 2 and 6. So if we add all these, what we will get? 2 plus 2, 4, 8 and 10. 10 plus 12 is 2, 4, 6, 8 plus 12 is 20. And now what we need is, we need additional 2 centimeters. Right? So let's try to do a thing here. We will just, I'm just erasing this. We will just try to shift it in a way like this, so that this additional is 1 centimeter and 1 centimeter. 6 will be same, 2 will be same here and 2 will be same here. Only these two additional distance of 1 and 1 centimeter has been added. So now if we are going to add these, let's see what we will get. We will have again 2 plus 2 plus 2 plus 2 plus 6 plus 6, 2 plus 2 plus 2 plus 2 plus 6 plus 6, and now this one and this one, which we have got by shifting the upper rectangle. So this makes 22 centimeter, which was required. Okay, so kids, practice these questions. These are very easy and also fun to do. So if you have any queries on this, please mail me and I will take them in the next class. And in the next class, we are going to move further in this chapter. Okay, thank you.